Good evening, sir.
So today we are going to start projectile motion. Today's topic is projectile. Projectile motion. Okay, so let's start. So when we call motion as a projectile motion, what is its difference between this and the 1D motion that we have studied? Difference is, when we talk about 1D motion, velocity and acceleration. Velocity and acceleration were in same straight line. Okay, velocity and acceleration were in same straight line. Okay, if velocity is in this direction, acceleration is in this direction, or velocity is in this direction, acceleration is in this direction. We call this as accelerated motion, and we call this as retarded motion. But velocity and acceleration were in same straight line. Okay, so 1D motion. But now in projectile motion, when we talk, velocity and acceleration are not in same line. Okay, velocity and acceleration are not in same line in projectile. Velocity and acceleration are not in same direction. Or in same straight line. Or in same straight line. Okay, there's a basic difference between 1D and projectile motion. I won't say 2D right now, because in 2D, you have circular motion also. Circular motion also is a part of 2D. So I'll define it. What is the difference between circular motion and projectile motion? That also I'll define. But at the moment, 1D motion means is acceleration and velocity are in same straight line. They may have angle 0 or 180. But here, when we say velocity and acceleration, they are not in same line. That means they have angle other than 0 and 180. Okay, angle between velocity and acceleration is neither 0 nor 180. That's why this is 2D motion. Okay, projectile motion is 2D motion. Or we call it as motion in plane. Motion in plane. Okay, note this basic information. Completed?
Yes, sir.
Okay. Right. So when we talk about accelerated motion, okay, then we already know when velocity and acceleration are in same direction, we have a motion called straight line. Now here I am saying velocity and acceleration are not in same direction. In fact, I would say that acceleration and velocity keep on changing the directions, or rather the angle between velocity and direction keep changing. When we talk about projectile motion, in projectile motion, angle between acceleration and velocity is not constant. Acceleration and velocity is not constant. Okay, there's also one point. Second point, in projectile motion that we are going to see, acceleration magnitude is constant. Magnitude of acceleration is constant. Acceleration magnitude is constant. Magnitude and direction also is constant because it's under g only, acceleration due to gravity. So in general, acceleration itself is constant, you write. Don't write magnitude alone, okay? Acceleration is constant in projectile motion. Okay. That is also fine. Okay. Based on this information, I'll give you one more information. What is that? If acceleration is constant, what type of motions are possible? Acceleration constant means is I am saying magnitude as well as direction is constant. Okay. So if acceleration is constant, what type of motions are possible for the particle? That's the question. Okay. Question is, if acceleration is constant, then what type of motions are possible for a particle? Okay, that's question. So if options I give you, and let's have the options also. Let's make it as MCQ. A, straight line motion. That's what we have studied, 1D. Okay, let's have projectile motion also. Third, circular motion. And fourth, a motion about which we cannot say anything. Okay, we cannot define. It may have different kind of a motion at different instants. So undefined motion. Okay. Undefined motion. So these are the 4 options. And this is a multiple choice. That means more than one correct answer is also possible. Okay. So if acceleration is constant, then what type of motion is possible for a particle? If acceleration is constant, then what type of motion is possible for a particle? Okay. Note the question. I'll discuss about the answer.
The projectile motion and circular motion.
Okay.
Yes, a circular motion.
Okay. Any other answer? Okay. So if acceleration is constant, then we can have 2 types of motion which are mentioned in this options. First is projectile. Both of you said projectile. Okay, that's correct. But second one is straight line motion. Circular motion.
So why is a circular is also possible now, sir?
I'm explaining you. Circular motion is not possible. Why? So I hope first of all, these first 3, that the first 2 points are there that you have noted already, right?
Yes, sir.
Have you noted?
Yes, sir.
And this
Yes, sir.
question also noted, right?
Yes, sir.
Okay, answer
Yes, sir.
also you tick so that I can go into the next screen. Okay. I'm going to the next screen. Now see, when you talk about circular motion, okay, let little bit of idea about circular motion also. So in circular motion, let's make one circle first. Okay, right. So here is a circle. Okay. So in this circle, I know that acceleration is acting towards center, which we call as centripetal acceleration, which we'll see in circular motion. But still, little bit of information you have studied, you have got in 9th and 10th standard. So if I say this is uniform circular motion. Okay, this is uniform circular motion. A particle is moving like this. So its velocity is in this direction. And acceleration is towards center. This is acceleration, which I am calling a centripetal acceleration. Correct. And if I say the directions, if I say this is east, this is west, this is north, and this is south. Let me assume the directions. Okay, so particle is here right now, its acceleration is like this. Next instant, suppose particle reached here and velocity is like this. Now, where is acceleration? Acceleration.
Towards the center.
Now, still you will say that acceleration's direction is same. It's towards center, no doubt about that. But is the direction same? Now, velocity is here. Where is the acceleration? Again, particle will come here. This is velocity. But where is acceleration? Check. Tell me. Is direction of acceleration same?
No, sir, not same.
No.
No, sir.
We cannot say acceleration is constant. Magnitude of acceleration is constant. Yes. Magnitude of acceleration will be v square by r. That's centripetal acceleration. That's constant. Why? Because speed is constant. It's a uniform circular motion. Speed is constant. So acceleration constant. Perfect. But direction is not constant. Direction keeps on changing. So that's why answer of that question cannot be circular motion. Did you understand that?
Yes, sir.
Yes, sir.
Right. So from this question, we understood that, or in fact, before itself, I told you that in projectile motion, acceleration is constant. Okay, so for a constant acceleration, two types of motion possible. One is straight line, another one is projectile motion, right? This part, shall I clear? Okay, you are
Yes,
noting
sir.
it. You are noting it, noted, no issues. Though I will tell you this again in circular motion, but okay, noted, no issues. Once you complete it, inform me so that we can move ahead.
Yes, sir.
Okay. So let's clear this one. Right. So projectile motion, two things we learned: velocity and acceleration. They are not in the same direction. Second, angle between them keeps on changing, right? Then what basically, if I want to define it, as in the books you will be seeing that projectile motion is there and there is a definition of projectile motion or a 2D motion. So what they say, okay, they will be saying that if you project a particle by making an angle with the horizontal or vertical. Okay, this is horizontal and this is vertical. So if you project a particle by making an angle, okay, you project a particle by making an angle with speed u, then the path it traversed is a projectile motion. Then the path it traverses is a projectile motion. And this projectile motion is under the influence of gravity. That means acceleration due to gravity is acting downwards throughout its motion. Then the motion is projectile. Okay, so how the definition is, we'll write it. When a particle is projected by making an angle. Let's say here I have taken theta. Okay, theta cannot be 0, cannot be 180, cannot be 90. Projected by making an angle with horizontal. Okay, first thing, when you have thrown a particle by making an angle theta with horizontal, then the motion is under influence of gravity. Okay, and the motion is under gravity which is in vertical direction. Okay, acting in vertical direction. You'll be saying that it always acts vertical. Why I'm writing it? Sometimes in place of gravity, you can have any other field also. Okay, it may not act horizontally. It may act horizontally. It may not act vertically. It may act horizontally. Then the motion will still be projectile. Answer is no. Okay, so that's why make it very clear. And the motion is under gravity, acting in vertical direction. Then the path of particle. Then the path of particle is projectile. Is projectile motion. This is the definition. Right? Note that one.
Sir, I have a doubt, sir.
Ask.
In that you said that theta can't be 0 and 180 and 90. So why it can't be 90 degrees? So if I'm throwing the ball and it is perpendicular to the ground, anyhow it will hit again the ground. So why not 90 degree?
That will be straight line motion, right?
How, sir? I couldn't understand it.
If you are throwing a particle vertically,
Okay, sir.
that is motion under gravity that we have studied in 1D, no?
Yes, sir.
So it's a 1D motion or projectile motion?
It's 1D motion, sir.
That's why it's not projectile, because projectile is 2D motion.
Okay, sir.
In projectile, you are traveling in horizontal direction also, and you are moving in vertical direction also.
Okay, sir. Now I understood. We should take the distance travel. Okay, sir. Now I understood, sir.
Yeah.
Okay, sir.
Completed?
Yes, sir.
Okay.
Yes, sir.
So let's discuss, like as one of you asked that if theta is 90. Okay. So if theta is 0, this is horizontal. And if theta is 0 means I'm throwing the particle like this. U is along horizontal. So it will keep on moving in horizontal direction. What kind of motion it is? A straight line motion.
Straight line motion.
Okay. Same way, if I'm going to throw a particle in this way, it is also along horizontal one. So it will keep on moving in this way. So it's again a straight line motion. Okay. 90, if I'm going to throw it like this, upwards, what will happen? It will go up. And in this straight line only it will come back. So it is also a straight line motion. So whether theta is 0 or 180 or 90, in all the three cases, motion is straight line. So you have to throw the particle with some other angle. then only it can be a projectile, so that it travels along y-axis also and along x-axis also. Okay. Both 2D motions, even in circular motion also, your motion is along y-axis also and x-axis also. That's why circular motion and projectile motion are called 2D motions. Okay, so I'm writing it over here. 2D motion means what? Motion along two axes. So motion along y-axis as well as x-axis. That means motion vertically also and horizontally also. In both the direction you need to move. Then only we'll be calling it as 2D motion. Is that clear?
Yes, sir.
Okay. Note this information, then I am going to ask you one question. Completed?
Yes, sir.
Okay. Vectors, everybody has studied or have the basic knowledge, right? About vectors.
Yes, sir.
Okay. Very simple question I am asking, not a tough question, very simple. Okay, questions. I'm giving you velocity of three particles, three different particles. Okay. First one's velocity is, let's say, v1 equal to 3 I cap meter per second. Okay. Second particle speed is 3 I cap plus 4 j cap meter per second. And third one, 3 I cap plus 4 j cap plus 5 k cap meter per second. These are all three velocities of particles. My question from you is, what type of motion are they performing? What type of motion are particles performing? Note question, think about it, and then tell me.
So first one is a straight line motion, sir, because it is traveling in a single axis. And next ones V2 and V3 are motion under plane, sir, because they have two axes like X and Y, and third one is X, Y, and Z. They have axes, sir, which means they have some.
Okay, so according to you, this is 1D, this is 2D, and this should be 3D.
Yes, sir.
Okay, is everyone agreed with that? Come on, tell me, do you agree with her?
Sir, is there anything called 3D motion?
Yeah, obviously.
Sir, I have not heard it before.
You will not study it. It's not there in your syllabus.
Yeah.
But 3D motion is there. Three D motion is there. Aeroplanes do it. Okay.
Yes, sir.
Aeroplane or maybe helicopters, choppers, missiles, they do. Okay. So what do you say? Do you agree?
Yes, sir.
My answer? Do I agree with that? What do you think? I do not agree. This is wrong. Which one is wrong? Second one.
Why, sir?
It's not 2D and it's not 3D. All three are 1D only. Why? I'll show you. This one, nobody is having doubt. So I'm not showing you the first one. Okay, second one. In second one, this is your y-axis and this is the x-axis. Okay, and the particle is having speed 3i cap plus 4j cap. That is, particle is going in this way. Right? Particle is going like this. Having an angle with horizontal. Yes, but where is acceleration? It's a constant velocity. So it will keep on moving like this. Straight line motion. Understood that?
So then we need theta and acceleration, sir. It's not only if we have theta or acceleration. It's not like we have to consider both of that, sir.
Yes. Acceleration need to be there.
Okay, sir.
Okay.
I just considered theta alone, sir. Okay, sir.
That's why I gave you question. That's why, because I know that, right? This is also
Okay.
1D motion.
Yes, sir.
This actually you can show it how it is. I'll make a cube and show you that. How is the direction? This will be actually along the diagonal of the cube, in which 3 x's are involved. Okay, this is the diagonal. Or rather, this is the cube. And in this one, the particle when goes in this way, okay, from this corner to this corner when it goes. This involves coordinates in 3 axes. All 3 axes are involved for the diagonal. So this is the velocity here. Now this is also straight line because it's not changing. Acceleration is not there. So that's also 1D. 1D, 1D, 1D. People, all the people do this mistake when you say, oh, here 2 axes are involved. So 2 dimensional. 2 dimensional doesn't mean that 2 axes for velocity is involved. No. Acceleration and velocity need not be in same direction. Then you may have projectile motion or 2D motion. 3D motion is what? 3D motion is when your motion changes the plane. Okay, when you are moving like this, suppose if I can show you, you are going like this. So this is 2D. Okay, from here you change the plane and comes out into this plane. Then you go in like this, then again go back into this plane. That's 3D. Curve motion. Motion has to be curved, but it needs to change the planes. Then you can say that it is 3-dimensional motion. Did you understand?
Yes, sir.
Okay. So question is clear, answers are clear. Note it fast so that we can move ahead. Done?
Yes, sir.
Okay. So let's come back to projectile again. So projectile motion, we said that there is something called horizontal, there is something called vertical, and we are throwing a particle in such a way that it's making an angle with horizontal, and it's motion under gravity. So this type of motion is happening, and we are calling it as projectile motion. So here we projectile, let's say with speed u, acceleration is g, and it's acting downwards. Okay, now what this acceleration is trying to do? Acceleration basically, if I take you a little forward in Newton's laws, we know that acceleration will come only when force is there. So what force do? It apply force on you so that you can come along with it. Then only the force is applied. If on any stationary object I am applying force like this, I'm pushing it, what will happen? That will be going in the direction of the force. So in this case, force is being applied downwards. Why is being applied downwards? So that the particle can move in the direction of force. That means move in the direction of acceleration. What acceleration always tries? It tries to bring the velocity in the direction of acceleration. Am I correct?
Yes, sir.
Are you able to understand? Acceleration means actually force. Acceleration always tries to bring velocity in its direction. If it's in opposite direction, we'll try to stop it. You cannot go in opposite to me. That means retardation. We have studied in 1D. What is retardation? Retardation means when you are applying the brake. So when you apply the brake, what happens to the vehicle? It stops. So what acceleration says or what force says? You cannot move opposite to me. Okay, that is what acceleration says. When you apply the accelerator, what vehicle do? It moves in the same direction as that of the acceleration. And acceleration is very happy. Good. You are moving in the direction in which I told you. Brake means it will say to the vehicle, you are moving opposite to my direction. You have to stop. Here, velocity in some other direction. So what acceleration tries to do? It tries to bring the velocity in its direction. That's why, see, here velocity is downwards. Yes or no? Not exactly in the same direction, but it's downwards now. Earlier you throwed it up, now it's down. So acceleration always tries to bring the velocity in its direction. Write that, okay? Acceleration always tends or tries to bring velocity in its direction, Okay. So it means is, in this case here, angle between acceleration and velocity will definitely be decreasing. Okay. From the starting point to finishing point, angle between acceleration and velocity must be decreasing. Why? Because if acceleration and velocity are in same direction, angle should be 0. Then only we can say they are in same direction. So if acceleration wants to bring velocity in its direction, that means angle between acceleration and velocity will definitely decrease in projectile. Let's see, is it decreasing? See now, here this is velocity, initial velocity is like this. And where is acceleration? This is acceleration. Downwards. So what is the angle? This is the angle. Okay, fine. It's more than 90. Yes, it's more than 90. Okay, it's more than 90. Let's go to the top here. Velocity's direction is this. Acceleration still downwards. What is the angle? It's at 90. Oh, it's decreasing. Here more than 90. Here 90. Let's see over here now. Velocity's direction is this. This is velocity's direction. Acceleration here. Oh, really it's decreasing. Are you able to see?
Yes.
Yes, sir.
In projectile motion, continuously angle between acceleration and velocity is decreasing. Important point. Note that.
So, but the angle between acceleration and velocity will not become 0, sir.
I'm not getting angle between acceleration and velocity
They'll not be 0, sir.
will not become 0. Why? Because here ground came. No, you cannot go further down. Right or
Okay,
not?
sir.
This is
Yes,
the final point. Now you strike the ground already. If you can allow it to move further, maybe at some point they will be in same direction. Okay?
Okay, sir.
So angle between velocity and acceleration decreases continuously in projectile motion. Right? Note that one. Done?
Yes, sir.
Okay. Okay, I'll try to erase this alone. Otherwise, I have to make this projectile again. I want to save my energy. Okay. Here it's gone. And okay, done. So here it is. Right. This also I don't want. Fine. So let's come on to the basic things about projectile. So initial velocity, we have thrown the particle with speed u. And this speed u is making an angle with horizontal. And it is traveling along horizontal also and vertical also. So always remember, whenever we talk about horizontal motion, it will be traveled by a horizontal velocity. When we talk about vertical motion, it will be traveled by vertical velocity. Okay. And this velocity is neither horizontal nor vertical. It's making an angle. So first thing we need to do is find its components along horizontal direction and vertical direction. Then only we can find out their motions in vertical and horizontal. So this u that we have shown is like this. And it's making an angle theta over here. This is horizontal along x-axis, and this is vertical. So the component along horizontal adjacent to the angle. Horizontal is adjacent to the angle. So this component will be adjacent to the angle always is cos component.
U cos,
And the other one is sine.
U sin theta.
Yes. This is u cos theta, this is u sin theta. Perfect. So I'm putting it over here. So horizontal velocity is u cos theta and vertical is u sin theta. And writing here also, ux, that means along x-axis, velocity is u cos theta. And along y-axis is u sin. Okay. Now acceleration is in which direction? Vertical or horizontal? Vertical only. Acceleration is only along vertical and it's acting downwards. Only vertical. So that means along horizontal, no force is there, no acceleration. Yes. Along horizontal, there is no acceleration. Along horizontal, there is no acceleration. So if no acceleration, that means no change in velocity. Yeah. No acceleration means no change in velocity, because acceleration is change in velocity by time. So if acceleration is 0, that means change in velocity is 0. So along horizontal, there is no change in velocity. Along horizontal, there is no change in velocity. That means u cos theta will remain constant. This is constant. Okay, fine. What about vertical direction? What about uy? Uy will keep on changing. Why? Because acceleration is there. Acceleration is there. And in fact, initially it's acting as retardation only. Why? Because u sine theta is upwards and g is acting downward. It's exactly similar way as if one particle we are throwing upwards. What happens? It goes to the top, maximum height, and then it returns back. So in the same way, this also will go, okay, to the top, and then we can see that this is the topmost point here. So it goes to the top and then returns back to the ground. Yes, it returned back to the ground here. Okay, so this velocity keeps on changing because g is there. So if I write vectorially, okay, I'm just adding vector here. Ux is actually I cap. Uy is actually j cap. And this ay is minus j cap. So retardation for this. So that means vertical component of velocity will keep on changing. There will be change in velocity. Vertical velocity keep changing as there is acceleration. As there is acceleration. Okay, are these points clear?
Yes, sir.
Note them. Completed?
Yes, sir.
Okay. All right. Now, if I ask you the horizontal component of velocity at this point here, at this point here, and at this point here, at all the points, its value will be what?
U cos theta.
U cos theta. Here also u cos theta. And here also u cos theta. Okay. Now, one concept I'm bringing from motion under gravity we studied. If you remember, I told you, if you are throwing the particle from the ground, then particle first goes up and then comes down. So at any height, the magnitude of velocity will be same while going upward and coming downward, or something like this. If I say particle is going up like this and then coming back like this, at this height, if while going up, its velocity, let's say, is v, then while coming down also, its velocity will be magnitude. Okay, magnitude of velocity will be same. If I am throwing a particle from here with speed u, then it will strike the ground also with speed. Do you remember that concept?
Yes, sir.
Exactly same thing we are going to apply here also. Now, at this point, at the starting point, what is its velocity? Upward. It is
U sine theta.
perfect. So here it is u sine theta. Now, this is on the ground and this point is also on the ground. So here what will be the velocity while striking the ground vertically? I'm not talking about horizontal. Vertically, what will be velocity? Same.
Use
Magnitude will be u sine theta. With whatever velocity you projected it upwards, with the same velocity, it's going to hit the ground downwards. U sine theta. So what I'm trying to prove? I'm trying to tell you that if this is angle theta, then this angle is also theta. Understood that?
yes, sir.
If angle of projection is theta, the angle with which particle is going to strike the ground is also theta. Both are same. Why? Because here, whatever is the velocity, exactly same velocity is here, only the direction is different. Here, velocity's direction is this. Here, velocity's direction is this. That is the difference. But magnitude is same. Because here, also horizontal component is u cos theta. Here also horizontal component u cos theta. Here also vertical component u sine theta. Here also vertical component u sine theta. So that is why this angle and this angle will be same. Is that point clear? So in a normal projectile motion, okay, normal projectile motion, angle of projection and angle of hitting the ground will be same. Angle of projection will be equal to angle of strike of the projectile. Okay, note that one also along with velocities. I'll come back to velocities again. Okay, note it. Done?
Yes, sir.
Okay. So now I'll make fresh one. All right. So projectile, initial speed u, angle of projection theta. This is u cos theta. This is u sine theta. And we discussed at all the points here, the speed horizontally is same. U cos theta here also, here also. And we also discussed this angle is theta only, as here vertical component is u sine theta. Okay. Fine. Now, at this point somewhere here, suppose this point, I am saying this point's coordinates are x comma y. Coordinates are x comma y. And I want to find that x coordinate and y coordinate. Assuming that we throw the particle from here, this is origin. And at this point, let's say this point is P. At this point P, particle reached in time t. Okay. Projectile reached point P in time t. In time t seconds. Okay. First thing, when we say projectile motion, we know that particle is traveling along x-axis also, and it is traveling along y-axis also. So that is why this point's coordinates are x comma y. Now let's see what x basically means. When we say this is the particle, so from here let's drop a perpendicular onto the ground. So x coordinate basically means is this distance, which is traveled horizontally. This is x. And y coordinate means this. That means how much you traveled along y-axis. That is the meaning of x and y coordinate. Okay. So along x-axis, with what speed you are traveling? So u cos theta. As I told you, when you talk about horizontal distance, you have to consider horizontal velocity, horizontal acceleration, everything horizontal. When you talk about vertical motion, you have to talk everything about vertical. Okay. So this x coordinate, I want to find x coordinate. X coordinate means what? Distance traveled in horizontal direction or distance traveled in x-axis direction. So x coordinate means distance traveled along x-axis in time t. So x is what? Now I have studied only one thing in equation of kinematics, which says x equal to ut plus half at square. Nothing else we know. So fine, x equal to velocity along x-axis into t plus half acceleration along x-axis into t square. Ux is what? Say u cos theta. Put it. U cos theta into t plus half ax, but there is no ax here. Ax is 0. There is no ax. Acceleration along x-axis is 0. Horizontal is 0. So x equal to u cos theta into t. Okay, fine. This is x coordinate. Then y coordinate. That also we have to find. Again, same formula. What same formula? Ut plus half at square. So y equal to uyt plus half ay into t square. Put values. What is uy? Uy is u sin theta. Okay. So y equal to u sin theta into t plus 1 by 2. Acceleration along y, is it there? So yes, it is there. And acceleration along y is actually g, which is acting downwards. Initial velocity was upward, and this is downward. Both are in opposite direction. That means what I'll write over here? Minus. So minus g square. So y coordinate? U sin theta t minus half gt square. Tell me, are both the things is clear to you? Any doubt is there?
No doubt, sir.
Okay, come on, note that. Note it. Y coordinate means distance traveled along y axis, that I have not written. Okay, y coordinate. Distance traveled along y axis in time t. Completed?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Right. So along x-axis distance and along y-axis distance that the particle has traveled, which we are calling as x and y, there is only one thing common in them. And that common thing is time t. Okay, if it is common, then from here, I am taking time and I am writing time as x by u cos theta. We are talking t equal to x by u cos theta. And this time I am going to keep in this one here. Okay, so let's keep it. Let's see what's coming. So this is all we have removed, and let's keep the time in that. So it's coming y equal to u sine theta into x by u cos theta minus half g into x by u cos theta whole square. So we are getting this u and u gets cancelled. We are getting y equal to x tan theta minus g x square by 2u square cos square theta. Okay, what this is relation between y and x coordinate. Okay, this is relation between y and x coordinate. Relation between y and x coordinate, which we also call as trajectory of projectile or path of projectile. Okay, this is also called as trajectory, equation of trajectory, or equation of path of projectile. So if anyone says you find relation between y and x coordinate, that means you have to find its trajectory equation or its path equation. That's called relation between y coordinate and x coordinate. Okay, so y equal to x tan theta minus gx square by 2u square cos square theta. Very, very important. You should remember it even in the night. Very, very important as far as projectile is concerned. If somebody make you get up at 2 o'clock in the night and ask you what is the trajectory equation of projectile, you should be able to say that. That way you have to remember. Y equal to x tan theta minus gx square by 2u square cos square theta. Okay?
Yes, sir.
All right, note that one. So it's the equation of path. What kind of path it is traveling? Certainly not a straight line. Certainly not a circle.
Parabola.
It's a
Parabola.
How do we know it's a parabola?
Because for a quadratic equation, it can be only a parabola, sir.
Yes, we can say this is kind of a quadratic equation, and for quadratic equation, it will be parabola. Now, it's which type of quadratic equation is there that we will see. Okay, have you done?
Yes, sir.
Okay. So this quadratic equation is of the form y equal to ax minus bx square. Because our equation was y equal to x tan theta minus g by 2u square cos square theta into x square. So A basically is tan theta and B basically is g by 2u square cos square theta. So sometimes they ask you a question like that. Suppose I give you right now a question. Let's make one question here. I give you a projectile motion is given like root 3x minus 2x squared. Find angle of projection and velocity u of the projectile. Find
60.
angle of projection and velocity of projection.
The angle is 60.
Okay. Correct, that is velocity of projection of particle. Okay, note the question. Then we'll solve it. Done?
Yes.
Okay. So what we can do in this one? Now this is equation of projectile and he's saying its projectile motion's equation is this. So we have to compare. Very simple, we'll just compare them. So coefficient of x here is root 3, here coefficient of x tan theta. So just equate tan theta equal to root 3. So theta equal to tan inverse root 3. This is how we write. The tan 60 value is what? Root 3. So theta is 60 degrees. So angle of projection is 60. Okay. This you know, right? Everybody?
Yes, sir.
Right. So theta is 60 degrees. Now the next thing is this factor. This is coefficient of x and here coefficient of x is this. So let's compare them also. So g by 2 u square cos square theta is equal to 2 here. It's 2. Now put theta value. You already have calculated. Okay. So put in this one. So cos 60. Cos 60 means 1 by 2.
1.
Yes, cos square 60. That means 1 by 2 square. So g by 2 u square cos square 60. That means 1 by 2 whole square. That means 1 by 2 into 1 by 2. 2 and 2 gets cancelled. Okay. Then this is equal to 2 actually. Here, this 2. Take 1 by 2 over there. So what will happen? G by u square equal to 1 by 2 into 2. This is also cancelled. What you got? G equal to u square. That means u equal to root g. That means u equal to root of 10. Okay. So we got initial velocity of projection also. And we got angle of projection also. Is that clear?
Yes, sir.
Note this one. You'll find many questions like this. Y equal to 3x minus 4x square, 6x minus 8x square. Many questions like that. So this is how we can do that. Completed?
Yes, sir.
Okay. Let's come back to what we were doing. Projectile. One more time I have to make. Okay. X-axis, Y-axis. This is projectile. This is angle of projection. This is U. This is U cos theta. Here is U sin theta. Acceleration is downwards. Okay. Now we can see that there is a point which we are saying is topmost point. This is the topmost point of the projectile. And here, what is the speed of the projectile at the topmost point?
0.
0.
U cos theta. At the topmost point, what is the velocity? U cos theta. Because U cos theta is everywhere.
Okay, so vertically only it will be 0.
Yes. So vertical component of velocity has become 0. Vy is 0. Okay. This is the highest point. So at highest point, Vy has become 0. So what is then maximum height? How to do? Simple. We know Vy is 0. So if Vy is 0, then I'll use Vy square equal to Uy square plus 2 acceleration along y direction into y coordinate. Vy square equal to Uy square plus 2 acceleration in y direction into y coordinate. Okay, Vy is what? 0. Uy is what? U sin theta whole square plus 2 into minus g into maximum height. That is our y coordinate. Maximum height. So what we are getting? U square sin square theta negative equal to minus 2g into h max. Minus minus cancelled. H maximum we got as
U square sin square theta by 2d.
Yes. Instead of writing like this or remembering like this, I would say you remember it like Uy square by 2g. Why? Because this is only the formula in vertical motion also. Because there we throw it with vertical velocity as u. So remember like this instead of u square sin square theta. Okay? This is maximum height. And in maximum height, what is 0? Vy is 0. Velocity not 0 in projectile motion. It remains u cos theta. Okay? And this is height maximum. Now I want time of ascent. Okay? So time of ascent now I want. TA. Now, time of ascent, normal definition is what? The time it has taken to reach to the top. Or the time in which its upward journey is happening. Downward journey has not started. Okay. So, time to reach at the top is time of ascent. Time to reach at maximum height. Time to reach at top. So when it reaches at top, what happens to its velocity? Vertical component became 0. So what he'll write? Vy equal to Uy plus acceleration along y into t. And this t only I'm searching because I'm writing vertical velocity as 0, which happens only at the top. So Vy is 0. This is u sin theta. Acceleration is minus g into t. So t equal to u sin theta by g. This is your time of ascent. But we will remember it as uy by g. This is time of ascent. Okay, is this clear?
Yes, sir.
Like this. Note this: maximum height and time of ascent. Completed?
Yes, sir.
Right. So time of ascent now we know, maximum height we know. Okay. Now let's write time of flight. Time of flight. Time of flight. Time of flight means what? The time in which the particle will reach back to the ground. It started from the ground and it reaching back to the ground. Definition wise, time for which particle is in air. Okay. Time for which particle is moving in air. Particle is moving in air. Okay, one thing is happening in that. What is that? Started from ground. If I say that this is origin, 0, 0. Then here also its vertical coordinate or y coordinate is still 0. X coordinate is there, but y coordinate has become 0. Here also 0, here also 0. Why? Because both are on the ground only. So on the ground, y coordinate is 0. What does that mean? It means displacement along y-axis is 0. Okay. It means when I am writing time of flight in this case, displacement along vertical direction is 0. So time in which vertical displacement of the particle is 0. Okay. So displacement we are writing. So displacement formula is what we learn in 1D, y equal to ut plus half at square. So we'll write y equal to uyt plus half ay into t square. We are writing y 0. Uy is what? U sine theta into t plus half, this is minus g into t square. Right. Then bring this one this side. Minus u sine theta into t equal to minus half g t square. This is minus half g t square. And this one came this side, so became minus. Minus minus cancelled. T cancelled. So t equal to 2u sine theta by g. Sine theta by g. Or 2uy by g. That's time of flight. Time of ascent was uy by g. Time of flight is 2uy by g. So what is time of ascent? Time of descent? uy by g. Okay. Time of flight is equal to time of ascent plus time of descent. This is 2uy by g. This is uy by g. Then what is time of descent? That is also uy by g. But other than this, one more formula I told you, if you remember, in motion under gravity, root over 2h by g. Remember that also. Okay, time of descent. If the particle is dropped, if the particle is dropped from height, then root 2h by g is our time of descent. Is it applicable in projectile? Yes, because projectile is also under gravity only. Okay, so that is also valid. Note this one. Completed?
Yes, sir.
Any doubt anywhere?
No, sir.
Okay. So time of flight, time of descent, and what else? Maximum height we have done. Okay. Then what is remaining?
Range.
Range. This x coordinate. We call this as range. What will be the definition of range? Definition of range is horizontal distance traveled in time of flight. It's called range. Okay. Horizontal distance traveled in time of flight is called range. Which is we represent with R. So horizontal distance will be traveled by horizontal component of velocity. Simple. X coordinate, if you remember, X coordinate we found in projectile when we were finding out path of projectile. What it was? Ux into t. Here also Ux into time of flight. That's all. Ux into time of flight. Why not acceleration and all that? Because acceleration is 0 along x-axis. That's why I'm not writing acceleration. Though the equation is s equal to or x equal to uxt plus half axt square, but ax is 0, so we are not writing. So range is ux into time of flight. Okay, what is time of flight? Time of flight is 2uy by g. Range formula. Remember this formula also. 2 ux uy by g. Put ux and uy, 2 u cos theta, u sin theta by g. General formula that we remember for range is u square sine 2 theta by g, but this formula is equally important. Just remember that I am writing. Okay, so r equal to, so here u into u, that means u square into 2 sine theta cos theta by g. So this 2 sine theta cos theta is sine 2 theta. So this becomes u square sine of 2 theta by g. It's important, no doubt. But this is also equally important. Just remember. Okay, note that one. This is range. U square sine 2 theta by g or 2 ux uy by g. Completed?
Yes, sir.
Yes.
Okay. So all basic terms we have completed. Now is a time for me to ask you questions. Okay, from basic things. So first is, let me make the diagram again one more time, same diagram. How many times I'll make, I don't know. Okay, u theta, u cos theta, u sin theta. Right, done. Now you are going to tell me question number 1. Question number 1. Write displacement of the particle as a function of time. No, don't write as a function of time. Write displacement of particle in time t. In time t. Question number 1. Second question. Write velocity of particle. Velocity of particle after time t. Basic things what we have learned right now, based on that only, write displacement of particle in time t and write velocity of particle after time t.
Sir, the displacement will be u square sine 2 theta by g.
No, beta. No. First you note the question, okay? I'll explain you. Noted, everybody? Students, have you noted question? Shall we start?
Yes, sir.
Okay.
Yes, sir.
See, after time t, this is not time of flight. It is any time t. So at any time t, maybe our particle is somewhere here, let's say. So its coordinates will be x and y. So when you have to write the displacement always means is xi cap plus yj cap. Remember always. And what is x? We know u cos theta into t I cap. Okay, u cos theta into t. What is y? U sin theta t minus half gt square j cap. This is displacement. Okay, in vector form. That's it. If he gives value to us, we'll find it. If suppose he says this is 3 and this is 4, we'll put it and we'll get the answer as displacement. So this is displacement. Okay, understood that? Remember it always. Displacement means you're actually finding coordinates, nothing else. U cos theta t and u sin theta t minus half gt square. I'll give you answer. Now, second question is for velocity. Now, who is going to tell me? You understood what I am asking, right? Can anyone tell me what will be velocity?
U cos theta plus U sin theta minus GT.
Yes, very good. So, velocity is Vx I cap plus Vy j cap. Vx is Ux only because along x-axis velocity don't change. So this is u cos theta. But Vy, it changes. Vy is actually Uy minus gt. U sin theta minus gt. Okay. So u sin theta minus gt. Somewhere I have written it when we are finding velocity. Where I written? When we are finding it at topmost point. I wrote this. Vy equal to Uy plus Ay into t. Okay. Remember this always. This will give you velocity at any time t. Same thing we have written. So this is velocity at any time t. If we give the value, again we can find it. One along x-axis, one along y-axis. Is this clear?
Yes, sir.
Okay, note that one. In the same one, I'll give you another question. First, you note these two. Completed?
Yes, sir.
Okay. Now, in this projectile motion, if I ask you any time, what is the direction of velocity? Remember that direction of velocity is always given by tangent to this path. These are all velocities directions. Okay. Like this. These are all velocities directions. Okay. These arrows are velocities direction. Now, my question. Third question in this one. Okay, third question is find or write angle made by velocity or velocity vector. Okay, velocity with horizontal at time t. At time t. Just note this one because you do not know how to find. So I have to tell you. Write angle made by velocity with horizontal at time t. Done?
Yes, sir.
Okay. So to understand how to make the angle with velocity, first we have to go to the point of projection. Point of projection is this point. Okay. Now in this one, you see horizontal component of velocity u cos theta and vertical is u sin theta. So we said that if we want to find angle made with horizontal, then we have to write tan of angle is actually vertical component of velocity by horizontal component of velocity. This will give us not tan of theta, tan of angle, suppose it's alpha. Tan of the angle that we are finding is actually equal to vertical component of velocity by horizontal component. That is the formula. So vertical component here is what? U sin theta. And horizontal component is what? U cos theta. This and this gets cancelled. So tan alpha is equal to what came? Tan theta. That means angle of projection is theta. Alpha equal to theta. Exactly same way. If I want to find this velocity, this is velocity vector. What angle it is making with horizontal? What is horizontal? This is horizontal. This is x-axis. So this angle I want to know. Suppose this angle is beta. Assume this angle is beta. Now how to find? Very simple. Tan beta equal to Vy by Vx. Is this is universal formula? Yes, it's a universal formula. Always it will be true. Yes, it is always true. So tan beta equal to Vy by Vx. Now what is Vy? We found little while ago. What was that? U sin theta minus gt. What is Vx? U cos theta. That's it. That's it. So tan beta equal to Vy by Vx. Once you have the value, keep the value. Beta will be there. Shall we try it over here? Yes, we can try it over here. This is the angle, right? Let's say this angle is delta. Tan delta equal to what? Tan delta equal to Vy by Vx. But what is Vy value? U sin theta. What is Vx value? U cos theta. So what is the answer? Theta. U sin theta by U cos theta. U gets cancelled. It is tan theta. So delta value is what? Theta only. We know it already. Did you understand?
Yes, sir.
So at any point you want to find what angle velocity is making with horizontal, immediately tan of that angle equal to Vy by Vx. That's it. Question is over. Note this one. Completed?
Yes, sir.
Okay, so let's close it here today. In next class, we will see more basics about projectile and we'll start doing numericals also. Okay?
Yes.
Okay, and bye-bye. See you in next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.